Hello everyone. Today we are going to discuss about the topic dimensions. See here, if it comes to units and measurements, dimensions is also very important. Based on that, we can do the dimensional analysis. See here, we have seven fundamental physical quantities and two supplementary physical quantities. Seven fundamental physical quantities: mass, length, time, thermodynamic, temperature, electric current, amount of substance, and luminous intensity. And the supplementary physical quantities: plane angle and solid angle. So here, by combining all these fundamental and supplementary physical quantities, there is nine base quantities that are presenting in SI system of units. Okay, so here nowadays every country is following the system international units, means SI system of units. So here, if it comes to dimensions, what are meant by dimensions? The dimensions means the powers of base quantities that are raised to represent a physical quantities. See here, if you consider a physical quantity, okay, what are the base quantities? Suppose if you consider a derived physical quantity like speed, if you consider a derived physical quantity is speed. Speed means what? The distance traveled by the time taken. Distance traveled by time taken. So here distance by time. So to derive the speed, we are considering two base quantities. One is the distance, which comes under the length, and time is another physical quantity. See, if you observe here, we can write this one as length by time also. Okay, the speed is a derived physical quantity in this. The length is representing the dimension, means here how much power is there, nothing is there, means we will consider it as 1. And the time also here, power 1 is there. So, what are the powers we are having, those base quantities powers will be represented as the dimensions of the physical quantities. Suppose if you consider acceleration unit, the acceleration unit is what? M s to the power of minus 2. M means what? Length unit, and s represents time unit. So here length, the dimensions of length in acceleration is 1, and the dimensions of time in acceleration is minus 2. The same way, if you consider the speed, the dimensions of length in speed is 1, the dimensions of time in speed is 1. Likewise, what all the powers we are having for the base quantities will be considered as dimensions. And the dimensional formulas will be enclosed in a closed bracket. Okay, square bracket we will consider, and here are the dimensional formulas of the base quantities. Mass in brackets, square brackets, capital M, length L, time T. See, if you observe here, mass, length and time, the first letters whatever we are having will be enclosed in the square brackets. Then if it comes to the remaining fundamental physical quantities, thermodynamic, temperature, strength of electric current, amount of substance and luminous intensity, for these four, what are the units we are having? Suppose if you consider thermodynamic temperature, the SI unit of thermodynamic temperature is Kelvin. So the symbol will be enclosed in the square brackets. The same way, strength of electric current A, amount of substance mole, and luminous intensity C, D. Okay, this is about the dimensions of a physical quantity. Then how can we write the dimensions of different physical quantities? We will see. Observe here. Suppose if you consider an example, force. The SI unit is kilogram meter s to the power of minus 2. Kilogram meter s to the power of minus 2. Kilogram represents what? Mass. So here dimensional formula. Kilogram represents mass. Then mass dimensional formula is what? M. And M represents the SI unit of length. Length dimensional formula is what? L. And here S represents what? The SI unit of time. So time dimensional formula is what? T. So T. And here after writing, observe here what are the powers we are having? Kilogram power 1, M power 1, S power minus 1. So the same way M power 1, L power 1 and T power minus 2. Okay, this is the dimensional formula of force. M power 1, L power 1, T power minus 2. Okay, in this way we will write the dimensions of different physical quantities. Density is equal to mass by volume. The formula of density is mass divided the volume. Then SI unit of density is what? SI unit is mass means kilogram. The SI unit is kilogram by volume. In terms of SI, length into breadth into height. Length unit is also meter, breadth unit is also meter, height unit is also same meter. Then meter into meter power 3. Then this can be written as what? Kilogram meter power minus 3. Okay, so kilogram meter power minus 3. If you observe the dimensions of mass, kilogram means mass only, no? So the dimensions of mass in density is 1. Why? Because the power of base quantity is 1. And here m power minus 3. So this is what? Length unit only, no? So the dimensions of length in density is minus 3. Then if you write the dimensional formula, see here, kilogram means mass unit and mass dimensional formula is what? Capital M. Then M represents what? Length unit. So length dimensional formula is what? L. T power L power minus 3. And here M power 1. Can we write this one? T power 0. Why? Because there is no dimension that is presenting here. Time dimensions are not there. So if you write T power 0, anything power 0 will be equal to 1 only, right? So again we will get the same as M power 1 L to the power of minus 3. Then this is the way to write the dimensional formulas of different physical quantities. Then what is dimensional equation? If we are equating the physical quantity with the dimensional formula, that will represent the dimensional equation. See, observe here. Before we have written force is equal to M L T power minus 2 kilogram meter S to the power of minus 2. M power 1, L power 1, T power minus 2 will represent dimensional equation. Okay, this is about the dimensions.